So, you've moved your data to the cloud, you know it's encrypted, but have you ever really stopped to ask yourself who's holding the key? Today, we're going to look past the default settings in Azure and show you how to architect a system that puts you in total control of your most sensitive data.
And really, this is the question in cloud security, isn't it? Your data is encrypted, which is awesome, but if you don't control the encryption key, do you truly control your data? That's the big idea we're unpacking today.
And this brings us right to the heart of the matter, the cloud data dilemma. Look, cloud providers give you fantastic security right out of the box, but for a lot of companies, that default protection is just the starting line, not the finish line.
So you might be asking, why would I need more than the default? Well, usually the push for more control comes from the outside. You've got regulators with rules like GDPR or HIPAA that are super specific about data handling. Then your biggest customers might have it in their contracts that you must manage your own encryption keys. And of course, your own internal security team is probably pushing for it to enforce a zero-trust policy.
Okay, so before we start building our own security fortress, let's take a quick look at the foundation Azure gives us by default. It's really good stuff, and understanding the baseline is crucial to knowing why and when you need to add your own layers on top. Basically, any data you write to most Azure services gets encrypted automatically before it hits the disk. It's totally seamless and really powerful. The main thing to remember here is that by default, Microsoft is the one managing the keys. They handle creating them, rotating them, all of it. For a lot of use cases, that's perfectly fine. But if you're in an industry with strict compliance rules, that's just not going to fly.
And that leads us to the solution, taking control with something called Customer Managed Keys, or CMKs for short. This is the mechanism that lets you become the true master of your own encryption. This is where you get to take the wheel.
The difference here is pretty simple, but it's also profound. On the left, you've got the default model. Microsoft handles everything for you. It's easy, it's transparent. But on the right, with CMK, you are in the driver's seat. You create the keys, you decide when to rotate them, you can even revoke access at any moment. Now, this does shift the responsibility to your shoulders, but what you get in return is that ultimate level of control that regulators and big customers are demanding.
All right, so if you're going to manage your own keys, you obviously can't just stick them in a text file on some server. No way. You need a purpose-built, super secure, and audible home for them. And in Azure, that place is called Azure Key Vault. I love this analogy because it's just so perfect. Microsoft builds the vault. It's physically secure, it's compliant, it's resilient. They make sure it's always on and protected. But they have no way of looking inside your specific box. Only you have the key to open it up and see what's inside.
And Key Vault is way more than just a home for your encryption keys. It's really a central vault for all of your application-sensitive credentials. You use it to store the keys for your databases and storage, but also secrets like API keys and connection strings, and even your TLS/SSL certificates. It becomes this single, secure source of truth for anything your app needs to keep under lock and key.
Okay, theory is great, but let's see how all these different pieces actually fit together in the real world. We're going to walk through a really common application scenario to see exactly how an architect would design a secure data flow using all these components. This is a classic. You see it all the time. We've got our application, and it needs to talk to two different data services, a SQL database for structured data and blob storage for files. The big goal here is to make this all happen without ever having a password or a credential hard-coded anywhere in our application.
Let's break this down. First, the app doesn't use a password. Instead, it authenticates using its own secure identity in Azure, called a managed identity. You can think of it like a corporate ID badge for your code. Second, with that identity, the app goes to Key Vault and asks for the database secret. Third, it uses that secret to connect to the database. And now for the magic part, which happens in the background. The SQL and storage services themselves are already configured to use your key, the CMK from that same Key Vault, to encrypt and decrypt all the data. The application never even touches the encryption key itself. So what we just walked through isn't just some clever one-off trick. It's actually a repeatable, scalable architecture that's built on a few core principles. Let's break these down into practical patterns you can use in your own designs.
It really boils down to these three things. First, stop using hard-coded credentials. Start using identities for your resources. Second, centralize everything sensitive. All your secrets, all your keys, put them in Key Vault. It's your single, secure locker. And third, for those high-compliance services, use customer-managed keys to take direct control of the encryption. If you can master these three patterns, you're on your way to building truly secure and scalable apps in the cloud.
But here's something you absolutely have to remember. A secure architecture isn't a set-it-and-forget-it kind of deal. Security is a process. It's something you have to operate and maintain for the entire life of your system.
And there are two operational practices that are non-negotiable. First up, key rotation. You need a policy and you need to stick to it for regularly creating new keys. This limits the blast radius if a single key were ever compromised. Second, logging. You have to turn on and, more importantly, monitor the access logs on your key vault. Think of it as your digital security camera. It gives you a perfect record of who accessed what and when.
And your goal here is 100%. 100% visibility. Every single request for a key, every attempt to read a secret, it has to be logged. This complete, auditable trail is what gives you real control, and it's how you prove you're compliant.
So the next time you sit down to design a system, ask yourself this question. Are you building it just to make the code work? Or are you building an architecture that's secure, that's auditable, and that's compliant from the ground up? Because in today's world, that's the difference between a system that just runs and a system that can actually be trusted. Thanks for joining me for this explainer.